I'm Bruce Nielsen. I've worked in computer software for 30 plus years, I think. Much of that was as a software project manager. I have an undergrad degree in computer science from BYU, an MBA from University of Phoenix. But about 10 years ago, I became obsessed with artificial intelligence, particularly artificial general intelligence. Now, mind you, that was before AI was such a big deal. It was just starting to get hot around that time, but LLMs weren't really a thing. So I did not foresee this huge AI craze. It's really just coincidence that I happened to go back to school in this right when it suddenly shot up. GPT-2, in fact, came out while I was working on my master's degree, which I'll talk about in a second. So I am the host for the Theory of Anything podcast, which is actually, well, as I mentioned, I was interested in the concept of artificial general intelligence. So I have a podcast that is secretly about artificial general intelligence. The name Theory of Anything podcast, you can tell that we allow ourselves to kind of drift around what we're going to talk about. And we have definitely done geeky stuff like Star Wars and Marvel and things like that. But if you actually look over what we've mostly done, this is, by the way, my logo here. It is mostly stuff related to artificial general intelligence or intelligence, concept of intelligence. Yes, I had an AI make that logo for me. The AI did a better job than what I had in mind, by the way. So I saw what it had come up with and I said, oh, that is like perfect for my show. And so I grabbed it and went with that. Most of the episodes are like a college lecture, often in technical detail about various subjects, usually related to intelligence in some way, such as animal intelligence, epistemology, theory of knowledge, machine learning, artificial intelligence topics, things like that. And as I mentioned, just about anything else. We did one on UFOs. So we've done a lot of different topics. So it's probably not for everybody. It is a little bit technical, but I have a lot of fun making it. And we've had a chance to interview and talk to many interesting people with intriguing ideas about AGI. So AGI is artificial general intelligence. So that would be AI that's at human levels of intelligence, in case that's not a term everybody knows. So my most recent interview was Kenneth Stanley, which I did last week, right during the AISIG meeting, so I couldn't make the meeting. So Ken is an AI researcher that is studying the problem of open-endedness. What? You've never heard of the problem of open-endedness? That's okay, nobody has. Which is a big problem because it is the big missing piece of AGI. In fact, let me go on a limb here and say you cannot and will not invent AGI unless you first know how to solve the problem of open-endedness. So it's kind of sad that most people researching AI don't even know about this Ken's work. He's relatively famous, but I don't know how many people know about the problem of open-endedness. So it's hard to believe that nobody knows about this, considering how important and crucial it is to the concept of intelligence and to AGI. It's also very crucial to the theory of Darwinian evolution. It's like a giant missing piece in Darwinian evolution that most biologists don't even know is a problem with it, that hasn't been solved. And if you've been listening to my very nerdy podcast, then you know about this problem because I seek out stuff like this and I find people to talk about them and I kind of bring them up and try to dig into them in detail. By the way, in the reviews of my podcast, one of the 5-star reviews, the guy said, "These are the nerdiest conversations I have ever heard." Amazing. It was the review of the podcast. So as I got excited about artificial intelligence, I decided to go back to school and get a master's degree. So this would be a second master's degree since I already had an MBA. And obviously I'm well past the regular age for a student. So I decided to go to Georgia Tech, the Georgia Institute of Technology, or Georgia Tech, and get a degree in machine learning. Now, Georgia Tech is ranked number 7 for their computer science master's program, at least according to the Google search I did. That number moves all around. They're almost always in the top 10. I think they were number 10 back when I was in school. Georgia Tech has an online campus, OMSCS, and it's really inexpensive. Like, I was in shock when I saw how inexpensive it was to get a master's degree from them if you use their online campus. It cost me only $7,000 for the entire degree. And it's equivalent to their, it's not like it's a special online degree. It is their regular master's degree. I currently work for Mindfire Technologies. I joined Mindfire Technology to be their artificial intelligence practice manager. I blog a lot on the Mindfire blog about artificial intelligence. If you go to mindfiretechnology.com/blog, or if you want to get to specifically mine, you can go to categories/artificial intelligence. That's probably too much to write down, but it's easy enough to find. And a lot of the blog posts are on artificial intelligence, and I'm usually the one who authors them. I come up with about one every week. And the posts include free code, links to free code, explain how to do it. And so we're going over a lot of the basics of how to get set up and get started in doing artificial intelligence, particularly with things related to large language models. So is AI worth it? So I actually stole this stat from somebody else who did a presentation for this AISIG, by the way. But there was a study done by Jacob Nielsen, and he found that the average job efficiency gain was 66% across different workloads for generative AI. Something like that's substantial. There's like huge potential with generative AI, large language models. Machine learning in general has got a very bright future. So we had clients that were interested in the idea of an AI tech support agent. So we created an initial demo for a client that had access to both their manuals and their database of past issues. And so let me just, I can't show a demo of that particular item. Some of that might be a little proprietary, but I've got some good examples here that kind of show what it did. So for example, imagine that this would be a tech agent that's actually not talking to the end user. It would be talking to a human tech agent, right? As a way of trying to help them out and teach them about their job if they're new. So imagine a tech agent enters, vehicle is a 2004 Ford Excursion, 2003 engine. The customer is complaining about a rough idle. There's a couple of codes that are set to talk about the high pressure oil system. They're using in whatever that product is and running at an economy mode for better fuel consumption. So this is something reasonably that a human could talk to a user, and they could get this information and they could enter it into the chatbot. And it came back with a list of matching cases, best matches. Now, the system that they have, it's just a bunch, you can imagine a tech support guy. They're not writing great English, right? They're just throwing sentence fragments into a system. And it's kind of complicated. It might be multiple callbacks, things like that. The AI actually summarizes it, puts it into nice English, throws the case number up there, and tries to concentrate on what's going to be the most important in terms of how does it match the problem that this person was looking for. Then it comes back and it gives a list of possible resolutions, and notice that it grounds the resolutions against the actual case IDs, okay? So it says, try these different things. And then it comes and it gives kind of a nice English, it's been taught to try to act like it's a tech agent that is an expert tech agent that's helping a junior tech agent. And it says, based on this information, blah, 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 why don't you try these things? And it actually tries to come up with suggestions. And again, you can see that it tries to ground it against various case IDs that are from their own system. Now, here is a slice from one of their manuals. They had a manual that included a troubleshooting section, and part of that said, if the camera picture is frozen, then that's due to a bad connection, and so try cycling the key off and on, okay? So imagine that you enter in that the camera picture is frozen is the issue that the user suggests. So here we're coming back with the possible resolutions, and notice that the top one, it actually looked up page 55 and said of the manual and said, oh, here, I've actually found this in the manual, and it gives exactly the suggestion that's in the manual. Okay, so we can actually put all their manuals in there, and that all becomes part of the knowledge base. And then it comes back and it makes a suggestion, and notice that it actually grounds it against the user manual. And it says, based on the user manual, a possible cause of the camera picture freezing is a bad connection. To troubleshoot this issue, it is recommended that you cycle the key off and on and double check the fuse and connector. So it grabs the text right out of the PDF that we put into the system, and it comes back and it utilizes that to help out the tech agent. So now when we built this, we still had a problem that we needed to deal with. And if you have like a big enough client, you can use ChatGPT, you could use Google Gemini, and they work amazingly well. And the results you saw there were, I think those were off of Google Gemini. But they can get really expensive. If you had a call center of 300 agents, and everybody was trying to hit this tech support agent, they're going to be charging you, less than a penny per token, but it's per token, and it'll add up pretty quick. So Nate, who's here in this meeting, he said to me, he's my boss, he said to me, hey, let's see if we can come up with some way that we can adapt this system to work for smaller clients, because I'll bet you that there's a lot of potential there. So, and then there's also data security concerns. A lot of people, they don't want to send their stuff out to OpenAI or to Google, and who knows what they do with it. Supposedly it's secure, yada, yada, but then you're sending your proprietary stuff over the internet, and potentially Google or OpenAI can utilize it, right? So the question was, how do we make it affordable, but also maybe even a local solution if necessary to try it for security reasons? So we started developing an in-house solution that uses an open source stack. So here's our stack so far. This is a work in progress. So I'll go over several things that we're currently doing, some that we're just working on, and some that are kind of future we're going to integrate in. So Hugging Face, maybe if you're in this SIG, there's a good chance you've heard of Hugging Face. They are a company that actually is the best in terms of collecting all the open source large language models that are out there, or just models in general. They don't do just large language models. They've got a whole bunch of access to these models online. They have code that you can, pip install into Python and immediately pull the models down, or you can stream them to an interface to their API, or set up your own. We have Haystack, which is by DeepSet AI. And I'll talk about Haystack a bit in a second if you're not familiar with it. Maybe a lot of you are already familiar with Haystack. So that it's kind of a big name right now in this sort of application. Postgres, of course, I'm sure everybody knows about PostgreSQL. And then PG Vector is an extension to Postgres that allows Postgres to handle embedded vectors, which I'll explain why that's relevant in just a second. Apache Age is another extension to Postgres, in this case to do graph database. And then these are ones that we're really not that far into, but we're starting to play with. LangChain, you've probably heard of. Neo4j is a database that's a graph database. And then Meta, I threw up there because of Llama. Llama is a free, not quite as good as OpenAI's ChatGPT, but it's Meta's version of it, but they made it as an open source and they made it available to anybody. And you can set up your own version of it and things like that. You can fine tune it, et cetera. And it's not just a service like ChatGPT. So you actually can get access to the model itself. So we're releasing a free version of our growing AI solution via our blog. Obviously, I do a kind of a dumbed down version of it and keep it simple. But we show how to set up the different parts of the stack. And we've got just tons of interesting stuff that starts from the ground up, how to get going and all this. And as I have to do kind of a mini project to demonstrate this. So I started working on what I call interview a book. So you know how you can, like today, you go into PDF and you got a giant PDF and they have a large language model built into it now, and you can actually interview your PDF. It's the same sort of idea, right? So this is all available on the Mindfire blog. I needed a freely available book. So currently I'm using the Federalist Papers. So I do everything with, you upload the Federalist Papers and then you ask it questions and it comes back with answers that are grounded against the Federalist Papers. However, in secret, I'm working on an AI version of philosopher Karl Popper. So Karl Popper, if you haven't heard of him, he is the greatest philosopher of epistemology. Epistemology is also known as the theory of knowledge. So a theory of knowledge is how human minds create knowledge. So obviously this is something that's would be very interest to a geek like me who's into artificial general intelligence. My podcast covers his theory of knowledge extensively as I've been studying it, trying to make sense of his theory. And so I want to recreate Karl Popper, an AI version of him, and ask him questions about artificial general intelligence, which is kind of ironic because he did not believe in the possibility of artificial general intelligence. That wasn't really a term. Like AI got invented, the term AI got invented in his lifetime. But he wrote whole books about how there was something special about human minds, and he actually probably would not agree with artificial general intelligence if he was alive today. So I'm going to get his opinions on it once I can finish making this AI version of him. So let me stop and just kind of show off what I'm currently doing. There isn't necessarily a ton to show, but this is all available free. You can get it off the Mindfire blog. So, and I'm doing a blog post on this, what we're going to show. There's no blog posts on, there's blog posts building up to a lot of this, but the one I'm about to show you is going to be coming out in the next couple of weeks. So here we have a query, and what I'm doing is I have a documents directory. So this is the book search archive. It's got a documents directory, and you can see that I've got a whole bunch of works by Karl Popper. Okay. And what I'm doing is I first have a document processor pipeline. I'll go over that in a second. And it is going to take these documents and it's going to embed them and put them into a database, right? So that we can do semantic searches against it. And then once that's in the database, which I have all these in the database now, then I'm going to query it. And here I'm going to ask, how are refutation, falsification, and testability related? Okay, so it's going to throw it through the pipeline, and it's pretty fast, but it's going to stream back an answer here, and I'll show you here kind of the answer and what came back to the user in just a second. So it comes back with an answer to that question. So the first thing that you saw, and it came back really fast, was that it actually pulls back document fragments. So that question that I asked, it uses that question to try to find the best matching, semantically matching document fragments. And you can see there's quite a bit of information available on what's called metadata. So it's going to come back with this. It's basically a paragraph out of a book. The book is called The Logic of Scientific Discovery. I've got it captured, which chapter it's in, which section it's in, the paragraph number in that section. Some of these have a page number. I will eventually probably have page numbers for everything, but the way they make EPUB files, they use different tags for different books, and I have to actually go look up what they did for each book and then improve my code to be able to find the page number tags. So it's going to come back with these hits, and all of these are across to different books, the most semantically matching. There's then a pipeline that feeds this to the large language model, and it's going to come back with this answer. And here it says theories can be evaluated based on their testability or falsifiability, which is a criteria of demarcation proposed by Popper. A theory is testable or falsifiable if there exists observation statements or potential observation events that refute or prove it to be false. It's actually a pretty good answer, right? So the truth is that I picked this as a kind of a trick question because to Karl Popper at least, refutation, falsification, and testability are all the same thing. So I wanted to see if it was smart enough, given this, that it could figure that out. And you can see it got a pretty good hit on that idea. Okay. Now, this is the other part of my code is I have all this stuff that's in this documents directory. If I run this, it's going to suck it all in. So I can either pass a single file to it, or I can pass a directory, and then it's going to find the documents in that directory, which is what I'm doing in this case. And you can see that, and I'm cheating a little bit here. This has already all been loaded, so it will load really fast the second time. If I were to try to load this for real, it would take like over an hour probably. But it's going to run through it pretty fast. And the reason why is because, as I'll show you my pipelines, is I check to see if it's already, as it's processing it, it checks the database to see if that document's already in the database. And if it is, it doesn't bother to load it. So it goes quite a bit faster because of that. So you can see that what it's doing here is it's grabbing sections out of an EPUB file. EPUBs are really HTML, so it's like a different HTML page for each section. And it looks at those, it kind of evaluates them. Some it decides to skip, so it sees, oh, this one's just a table of contents, so it's going to skip over that because I don't want that. If there's something that it tries to take in and I decide I don't want it, like the index here, I can actually put it into a file. There's this file of sections to skip that I just throw it in there, and then it'll skip it on the next run. And by doing that, I can eventually end up with a fairly pure set of text that is really the writings of Karl Popper. Doesn't include tables of context or indexes. I did want the notes though. Like a lot of Popper's notes, footnotes, are really important stuff that he wrote. So I wanted to make sure I did include like footnotes. That's a little annoying. I do a few tricks to try to deal with that. But the net result is that I've got a pretty good set of documents from him. I split it up into paragraphs. I throw it into this database, and then I'm able to semantically search it. Okay, so let me go back to my presentation. And
recording in progress.
Okay, so all of this is what's known as retrieval augmented generation. I'm sure you guys are familiar with that term. And I don't know if you'd be familiar with cosine similarity or not, but retrieval augmented generation is based around, well, it could be based around, it's often popularly based around semantic search, which is often popularly based around cosine similarity. So this is the formula for cosine similarity. You don't need to understand it. Obviously, it looks a little intimidating. It's not really that complicated a concept, though. If I were to take these two lines and look at the degrees, angle degrees between them, I could use cosine similarity to see how similar the two lines are. So imagine that you take a bunch of text and you embed it using a text embedder, large language model to embed text, or maybe something that's specific to embedding text sentences. And that now exists in a hyperparameter space and is basically some sort of plane, right? So it's like a line, but it's just a hyperplane. And you can use cosine similarity on it. The formula doesn't care if it's a line or a plane or a hyperplane. The formula works on any sort of surface like that. And because these things are embedded to where similar, the large language model is going to have different words that are going to be similar, like if synonyms will be close to each other in the embedding space, the cosine similarity will find a semantic similarity by using cosine similarity. I don't know if that makes any sense or not, but it's basically just straight math, and it finds good hits based on synonyms or whatever you want. So now there's a problem. Cosine similarity is pretty slow. Like you have to literally embed every single one of the paragraphs you saw me loading, and then you have to embed the user's query, and then you have to compare every single one. It would take a very, very long time to do it. So the solution to that they invented is something called hierarchical navigable small worlds. And there's detail about this on the Mindfire blog, by the way, if you want to look into this any further. Now, this is built into PG Vector, which is an extension to PostgreSQL. So I didn't have to like code any of that. It's something that I just load PG Vector and it's going to do this for me. But you can kind of see this comes out of the HNSW paper, where they actually show that instead of having like this graph of nodes together, that they actually have it to where it gains detail at different levels. And that's how they make it so that you can do a very fast cosine similarity. Okay, now there is a downside to doing HNSW, and that is that it doesn't really do a cosine similarity against everything. Instead, it relies on the fact that it's going to find something close to the best match. Now, I did some experimentation because I wasn't sure if I trusted it or not. So I tried experimenting with doing a straight cosine similarity and checking everything, and then trying PG Vector's HNSW. The results were almost as good. They slightly worse, but they were way faster. Like it's not even close, right? It's orders of magnitude faster. So because of that, that was the solution that we ended up going with. So Haystack, I mentioned, is an open source software from DeepSet AI. They allow you to create graphs that are workflows. So it's too big to see. I'll zoom in here just a second, but here's my document conversion graph that I created. So if you were to look at this a little closer, you can see that it's just basically a series of steps that it runs through. So I'm going to have an HTML to document. So I'm loading EPUB files. Those are really HTML. So I'm going to feed them into the HTML to document node that comes with Haystack. It's built into Haystack. Then I have a custom built component. So some of these are built into Haystack. Some of these I wrote myself. It's going to remove illegal documents. Haystack can actually do that for you, but I didn't trust it, so I wrote my own version of it. It's got a cleaner where it tries to clean up the text. It's going to split it. It's going to attempt to split it into different sizes. Now, I didn't like the built-in one for Haystack, so I wrote my own, and I'll explain why in just a second. And then it's got this duplicate checker, and then it's going to route it, and it's going to say, okay, we do have documents. Let's embed them, put them out to the writer, and it's going to write that out to Postgres. And then at the very end, it just kind of gives me a result at the end of the number of documents written out. So I wrote this custom document splitter instead of using the built-in one. And the reason why is the one that's built in, you can say like, oh, I want this many sentences, or I want this many overlaps of sentences. And I do actually use the built-in one inside of my custom one. So I didn't like give up on that functionality. But I wanted to really try to make it so that I was embedding a paragraph of text from the book. I didn't want it splitting it up into its own little paragraphs. And my thinking was some human bothered to put this into a paragraph, and humans are probably better than any large language model in terms of what is semantically interesting together, right? So I didn't want to give up on that. So that was one of the reasons why I went with EPUBs instead of PDFs. So I attempt to bed each paragraph, but the human paragraph might just be too long for a text embedder. Some of them could definitely handle it, but you don't want them to be too long because then it just starts to muddy the waters too much for the semantic search. So what I did is I will attempt to embed it, and then if it doesn't fit, I'll actually check to see if it's truncating the text or not. And if it is, then I will move to using the built-in Haystack one, and I'll try to split it up by sentence. And then I do a duplicate checker where I actually query the database and say, hey, does this document already exist? If it does, don't bother to write it. And the reason why I did that is because Popper had some of the exact same essays in multiple of his books. And so I wanted to only contain it once in the database and not have duplicates. So I had to write something that would take care of that for me. So, what I kind of mentioned why I'm doing EPUBs instead of PDFs. The truth is that PDF parsing is built into Haystack. So I can do both, right? Like I wanted to be able to have access to both because some of Karl Popper's stuff's in PDFs and some's in EPUBs. But if I have a choice, I really want EPUBs. And the reason why is because EPUBs are HTML. I can then use Beautiful Soup. That's a popular library in Python for parsing HTML. And I can use that to create that metadata that you saw, where I get chapter names and page numbers and things like that. I'm going to use this as a research tool for like my podcast and such. And I need to not just have the text, I need to know what book it came out of and things like that. So I really needed that metadata if I could possibly get it. And I feel like I can then use it. I could theoretically embed it and do searches on it. Like it just, the very fact that I have it is just something useful in and of itself. So here's my actual RAG pipeline that does the actual interactions with the LLM. So kind of a zoomed in version. You can see that I take the query and I'm going to send it off to a lexical retriever and a semantic retriever. So a lexical retriever would just be a normal word search, which is functionality built into Postgres already. And this is the semantic retriever, which is the cosine similarity that I get with PG vector. I collect the results and I score them. And it comes back with a score for each of these. And I'll like merge them together. And then if there's a match between the two, then I use that as a good sign and I'll actually give a bonus to each other so that it kind of raises in the ranks. Then I feed that off to a prompt builder, which then kind of puts together a prompt that's going to go to the LLM, and it's programmatically knows how to build prompts that are appropriate for whatever came back. And then it's going to throw that off to the LLM. In this case, I'm using the Hugging Face API generator, which means that it's not a local large language model. It's one that Hugging Face is hosting for me. I'm using their rate limited one, basically, which is free. And you saw that it was quite fast. My code works with all those, though. I could use a local model. I could use Gemini. I could use like anything that you want to throw at it. So I could just like switch the models out at will. So for the streaming response here, I kind of already mentioned this, but I combined the lexical and semantic search together. Once it goes into Postgres, PG Vector adds the ability to store embeddings. You can kind of see here, this is Postgres admin. You can see the vector. There's just a bunch of data numbers there in a vector, and you can see that it corresponds to content, which is the paragraphs. And then I'm going to add Apache Age to get graph functionality as well. The large language models that I'm currently have experimented with are Hugging Face's streaming API uses Zephyr 7B Alpha, which is really a fine-tuned version of Mistral, which you may have heard of Mistral because it's, at least if you're into open source models, that's like a really big name. Pretty good results with Mistral. What happened was Hugging Face made a kind of optimized version of Mistral that they then hosted on their API. So that was, I can get a fairly effective large language model for free if I'm willing to use Zephyr. I also use Gemma I have a local LLM on my laptop here. Laptop's not that powerful, so it's going to be a little bit slow, but probably the best I can do here is Gemma. Now, what's Gemma? Gemma is a local version of Google Gemini that's been shrunk down or quantized so that you can use it on a laptop, right? And it's not going to be as good as Gemini, and it doesn't have as big as a context window, but it's really pretty effective. And they made it open source and they released it, and they have larger versions of Gemma, more powerful versions of Gemma. I'm using one of the least powerful versions, but it's still giving me decent results. And then I've actually used the API, Google's API, to do Google Gemini. And we're currently working on a Meta Llama 3 version that we're going to stream from our own AI box and use. So, and then this is kind of what I have now. There's all sorts of things that we're planning to add that we will cover on our blog in the future. Some of these are easy. Like I need to do a re-ranker at some point where once I get the results, I kind of have it re-rank and say, well, which of these are, now that I have the results, which of these are really the best results to use? I want to use a large language model to rewrite the tech support notes. So you can saw how it kind of summarized it. We had some struggles with trying to use the tech support notes to fine tune a model. And you don't really necessarily need to have to fine tune a model, but that's something that we want to also be able to do. And so we're planning to write something that will like take kind of the half-written English of a tech support person, and then it will rewrite it into nice English that we can then use for fine tuning. And the large language model, we want to be able to use one that is a program that will take manuals and create like a knowledge graph out of it instead of just doing semantic search. And then we want to integrate with a whole bunch of various products that are out there that are open source. That not all of these are open source, but most of them are. Llama File, Llama Index, Chainlit. Llama Index in particular has something called Llama Parse, which you feed it a PDF and it will actually like read stuff out of tables and things like that. And it apparently does a very good job of sucking in data out of a PDF. NeuralDB for embedding without, so not needing to embed to do indexing, which is kind of an interesting idea. DSPy for prompt tuning, Elasticsearch, Streamlit for a customizable UI interface to go in the front of it. Obviously, I'm just doing command line at the moment. And then improve semantics text chunking. Like I said, I'm getting a human do it. That's why I'm doing EPUB. But when I start playing with other things, I can't always have EPUBs. We want to be able to build a module that figures out, okay, these sentences semantically go together, and it makes its own paragraphs that are intelligent. And then like adding architectures like chain of thought, like that's what the new OpenAI 01 does, or the React architecture. Basically, they're architectures that allow the large language model to ask itself questions, and then it has function calling where maybe it goes out to Wikipedia and looks things up, and then it can try to pull in data to try to enhance its answer before it gives the answer to the user. So that's kind of what we got. That's the end of my presentation. Any questions?
So Bruce, out of all the open source LLMs, which ones do you prefer in terms of speed, accuracy, minimal hallucinations, etc.?
So in terms of if you have to like run it on a laptop, Gemma is by far the best that I've come across so far. So I actually would recommend that. I don't know that Gemma is a nearly as good a solution as Llama. Llama is huge though. I could never even load it on my laptop. That's why we have to do it on a separate AI box. But Llama is probably the best one at the moment. Llama 3 is probably the best one at the moment. That's Meta's. So
yeah. Okay.
Meta is Facebook for those who don't remember that. It's hard to remember that they changed their name.
Yeah. So are you seeing a lot of companies that are looking to get this type of RAG functionality?
Yeah, good question. So I think that there is a lot of interest in it, but there's also a lot of nervousness around it. So you've got kind of some bleeding edge companies. You got a lot of bleeding edge companies that are doing this. They can afford to use OpenAI. They can afford to do something that's expensive. And that's, without a doubt, that's going to give you the best results. If you can afford that, I don't think there's any doubt that Gemini and ChatGPT and maybe Claude are the best for pay models that are out there right now. Depending on what you're trying to accomplish, right? And I think that the smaller companies, they kind of perk up over the possibility of what we could do with this. But that's actually why we've been trying to build like something we can show off to them, is we want to kind of come in with something and we can say, look, we've got like, here's what you could actually do, right? And perk up their interest more instead of just being hypothetical. And say, look, we could do this with your data, right? And we can make it so that this knows your products. And if we were doing something like a tech support agent, it knows your products. And we want to build a business case for that we can kind of take in as a sales pitch to these smaller companies. But everybody asks about it, right? Like a lot of times we build interest in the company just by talking with them about AI, but then they don't even want to do an AI project. They just want to talk about it. You know, it's something that's so hot right now that it's on everybody's minds.
Yeah. And then I thought it was interesting, the agent that you created for the call center or for the IT tech, the tech support, where it was not an agent for the customer, but it was an agent for the agent,
Yes.
the human agent. And it came back in text. Have you looked about retrieve that information, retrieve that text, but then present it in audible voice instead of text?
Yeah, so that wouldn't be particularly hard to do. I again, there's the pay issue. If you want to use OpenAI's Whisper or whatever, then you could pay for that, and then that would be trivial to actually throw together. But there are open source versions of that, so that would be something maybe we could tack on at the end and have it so it could actually talk to you. And you could even theoretically have it where you could just talk back to it, and it would.
And to be clear, one of the
conversation.
reasons we do it this way is because we don't want to have to spend our time putting guardrails on this thing. So the only people who are going to be using it are kind of already internal. So we don't need to worry about, you know, if it can tell you how to rob a bank or cheat the system or anything like that. Because guardrails are A, really expensive, and B, really difficult and disastrous to get right or wrong. So
Yeah.
And having it so that it's used by the human tech support agents, there's an obvious case here, business case for, hey, you know, it's so difficult to train up your agents, and then they leave, right? Because they get this knowledge and then they take off. They're like some depending on which study you're looking at, this can range anywhere from like 13% to like 40% turnover per year for tech support agents. So having it something where they can become valuable immediately and it kind of trains them has an obvious business case, but then you're also building it up to where you can eventually use it to replace the tech support agents. So like at some point you could get some experience with that and fine tune it and things like that. And then you could say, you know what, we could actually start to see if we could let people, the users actually self-serve through an automated agent. But that, you know, that is definitely building the guardrails. That's where all the expense really is, right? So that's probably not something that a smaller client's going to be interested in doing right off the bat.
Makes sense. I'm sure other people have questions. Anyone else on the call today have questions for Bruce?
It's funny, when I think of Bruce, I think of him just as a project manager. You know, you've been busy in the last few years.
Yeah.
Bruce was with our company for about 15 years in the past before he moved on a little bit. So before we'll steal him back one of these days, but I'm just impressed with the variety of different tools that you've been able to find. How long have you been just really, how long did you start this?
How long ago did I start working on this?
Yeah.
You know, that should be an easy question to answer because it should be on the blog. Let me actually check. So, I mean, I've been blogging on the blog for a very long time, but like we started in earnest. In fact, if you go back and you look at my very first blog post for Mindfire, I wasn't even working for Mindfire at the time. The first one is a causal inference, and I wrote that back in 2019 for them. But if you really look at kind of when I started in earnest on this, I would say it would be the post that was on March of this year.
So prior to March of this year, how many of these tools had you been already familiar with? The open source tools that because there's a lot of different moving parts that you've put together for this.
Yeah. So the honest truth is I think I discovered all of them since March of last year. So I I was really like, when you're in school, you're studying the theoretics, right? They're not teaching you open source tools. They're teaching you the math for how things work and what the theory is and stuff like that. So I had really concentrated more on that initially. And I mean, you have to look at this from the standpoint of, I was a project manager that suddenly got bitten by the AGI bug, and I really wanted to understand the theory behind it. And then once I had trained myself up, it's like, oh, well, let's put together an AI solution that does this. And probably it was Nate's idea. I don't remember how we got this all started. It kind of evolved over time, but it probably was Nate's idea. Nate's on the call here. And I had started to do these posts, and Nate's like, we could totally do something with this. And so then we started to, I started to pull together open source tools to make it work and building a stack. I think initially I was using 4Pay stuff. And I think, again, it was Nate who pushed me and said, you know, Bruce, if you could figure out an open source solution for this, like, we'd have a bunch of clients. So then I started like studying open source solution versions of it and things like that. And so it's kind of something that's evolved over time from there.
Well, good on you. I mean, it's inspirational. So that's awesome.
I agree. I think undoubtedly the smartest person in the room is Nate for hiring you.
I'll take it. Yeah.
Nate probably is the smartest guy in the room. I do have to admit that. Every time I get stuck on something, I go to him and I get him to help me with it. Even if he doesn't know anything about it, he always figures it out for me. So.
Is Nate on your blog or on your website too? Mindfire site?
Oh yeah, Nate does. So I've been kind of dominating the blog recently, but like, I suspect Nate's done most of the posts on the blog. The blog goes back years, obviously. But so just Nate actually got excited about AI, and he's like, Bruce, will you please do like a weekly blog post? And then he actually asked me to do that before I started doing it. I have a lot going on with a family situation. I have a sister who's very, very ill, and I had my other sister move in with me. So I kind of put off getting into that for a little while. To be honest, I was just struggling with the situation. And so eventually I started to do it, and Nate kind of kept tapping me, when are you gonna started giving me blog posts, and then I started getting into it, and then I started doing it every single week. And and it's kind of like my hobby now, right? Is it every time I get a free chance, I start writing a blog post and adding more to my open source stack, and it's kind of got me excited now. So I has something that I do for fun. I'll do it while I'm watching television. It's something that I just keep working on and keep improving.
I just wish I had more time to write more blog posts myself, but I can always commission Bruce to do it. So,
Well, thank you for doing this, Bruce. I have a hard stop, so I need to go, but thank you.
You're welcome. Thank you
Yeah.
for inviting me.
I think we're at the top of the hour. So thank you very much, Bruce, for joining, and look forward to having you join on our weekly calls. But thank you for presenting today, and we'll see everyone else next week on this call. Thank you.
All right. Thanks.
See ya.
Bye-bye.